Today, in this lecture, we have a chapter which name is going to be vector. And details, I will share all those information, all those important topics which will be related to vector chapter. Yeah, whatever you heard right now is correct, is right. Vector. We will start this lecture from starting and we will end this till the advance. Some questions will be taken. Before we will take some question, we will understand all those important topics that are very important from this chapter. Let's start with the meaning of vector. Uh, is this visual for you? Can you see this word text? If yes, okay. So tell me, what do you think about the vector word? Is this only word? Has it voice? Okay, let me explain. Vector. Remember, in the field of vector, we take physical quantities. In our world, there are a lot of quantities, as you know. In our world, there are a lot of quantities, and we we divide all those quantities into two parts. So first part is known as physical quantities, and second part is known as unphysical quantity. Now, what is the definition of physical quantity and what is the definition of unphysical quantity? With example, we will I will tell you. So physical quantities are those quantities, any quantities you are taking. Okay, if you are able to measure, if you can measure that quantity, then you can say that quantity is a physical quantity because you are able to measure. Okay, this was about the physical quantity. Okay, it is done. But what about non-physical quantity? What about the non-physical? Just opposite of physical quantity. We saw about physical quantities is it is a quantity which can be measured. Okay, physical quantities can be measured. So unphysical quantities cannot be measured. That's it. It's not rocket science. Now let me explain this with example. This is marker. I ask you, what is the length of this marker? A lot of a lot of you a lot of you would say that length of this marker would be 1 2 3 4 approximately 5 centimeter. Okay, let's just say length of this marker is a 5 centimeter. Here you are saying 5 centimeter. It is nothing but measurable. We can measure this. Now after measuring this in length, we are getting 5 centimeter. So here we can say this is a physical quantities. Okay, this length is a physical quantity. This was an example of physical quantity. Clear? Wind, not wind, heat, love, light, sound. I'm not saying intensity of a sound. So love, light, sound, hate, crying, all these are non-physical quantities. All this cannot be measured. That's why I'm saying that all these are non-physical quantities. Clear? I ask you, what is the length of this board and width? Length, length and width. You would say, okay, let me bring measurement. Then I will tell you what is the length and breadth of this marker of this board. Here, can you see your confidence? You are saying, okay, let me bring measurement so that I can measure this board in length and breadth so that I can give you exact length and breadth of this board. This is your confidence, and this your confidence is saying that you can measure this board. So now you can say that this is measurable thing. When it comes to measurable thing, you can also say that this is a physical quantities. This was about physical quantities. Okay, non-physical quantities are those quantities which cannot be measured, and this physical quantities and non-physical quantities both are present in our body. Just we divided we divided all those quantities into two sections. In one section we have physical quantities, and in another section we have non-physical quantities. That's it. Now, why did we understand about physical quantities and non-physical quantities? Because there is a connection. There is a connection of physical quantities for vector. For vector. I'm not saying non-physical quantities. Okay. You would realize connection of physical quantities with a vector. Here, vector is nothing but this is a physical quantity. Vector is a physical quantities. Clear? A scalar. As we were discussing about a physical quantities and non-physical quantities, the same here we will understand about the vector quantity and a scalar physical quantity. Okay. This both are physical quantities, not unphysical quantity. Vector is also physical quantity, a scalar is also physical quantity. But what's the difference between them? This is main question. What is the difference between vector and the scalar? Already we have now that vector is a physical quantity, a scalar is a physical quantity. Remember, here we can measure vector quantity. We are able to measure vector quantity. But condition is it will provide direction and magnitude. Magnitude is a combination of a unit and number. In simple word, we are saying that vector is a physical quantity. When it comes to physical quantity, it means we are able to measure physical quantity. And when we will measure this physical quantity, vector physical quantities, we will get two things. First magnitude and another direction. This magnitude and direction is nothing but vector. Clear? And this magnitude and direction we will get when we will measure. When we will measure physical quantity. I hope you are understanding. Okay. I will clarify you with examples, don't worry. Next we have a scalar quantity. Let me explain about little bit about a scalar quantity. So a scalar quantity is also physical quantity. I have already said it. It is also physical quantity. But when you will go to measure physical quantity, and that physical quantity is providing only magnitude, not a direction. Not a direction, only magnitude. If a physical quantity is not provided direction and it is only providing magnitude, this type of physical quantity is known as a scalar quantity. That's it. Okay, so in the case of a vector quantity, we were observing that it provides magnitude and direction. But in the case of a scalar quantity, we are observing that it is not provided direction, but it is able to provide magnitude. This is the difference between them. Okay, so let me bring one example or two examples for both. displacement, I would say displacement, and in this distance, displacement is an example of vector and distance is an example of a scalar. We can't say that distance is a vector quantity. No, you can't also say that scalar is a displacement is a scalar quantity. No, it is wrong, because distance distance only, this will provide only magnitude, not a direction. When it comes to displacement, it also provides a direction as well as magnitude. When we say length of this road, this straight road is uh, not length, I would say uh, there is a one object, and that object is covering this much distance, and distance is 250 kilometer. So a vehicle is covering a distance of 250 kilometer, and a road is straight. A road is straight. So this 250 kilometer distance, and this object is covering this much distance in, I would say, in south direction. In south direction. So this is south is a direction. So 250 kilometer is a magnitude, and south is a direction. We are getting two things: displacement from one perspective, displacement and distance both are same, but there is a one word which makes both of them different. That is that it does provide direction, but it does not provide direction. This is the main difference. I hope you are getting my point. Now, in this section, our whole focus will be on vector, not a scalar. Okay, our main focus will be on vector. After understanding meaning of a vector, representation of a vector, then we will see types of a vector. Then we will have rules. There are three laws of a vector: triangle law, parallelogram law, and polygon law. These are three. After this, we will have a what, dot product, which is also known as a scalar product, and then vector product, which is also known as a cross product. All these are our, I would say, main topics for this chapter that we are going to cover. Hmm? I think so. I have told you complete a complete definition of a vector. Now let's see how to represent this. Right? It's not rocket science to represent this vector in mathematics. Just a symbol. This is symbol. This is symbol is nothing but that is how vector is represented. I am talking about this symbol, arrow, arrow. So by drawing a arrow, we can represent a vector. This is how you will represent. Right? Okay. Now you can. This is not complete. It's just a symbol. It is just a direction. Okay. This is direction. Here, it's a complete. This is complete. We would say this. We would we would pronounce it like this. Vector A, vector B, vector R. Like now, let's break down this arrow. This line segment is nothing but magnitude, and this arrow is a direction, and this complete is a vector. So this line segment will be only magnitude, and this arrow will be vector. Okay. Okay. Now one thing more. This ending part and this ending part. We have two ending part of this arrow. So this ending part is known as something else. So this ending part, name of this ending part is tail, and name of this ending part is tail. This is head, this is tail, and this is head. This is tail, and this is head. So you will observe use of this head and tail when we will be discussing about laws of triangle, okay, laws of parallelogram. Then you will observe importance of this understanding tail head. You would not say that this is a head. No, this will it is a fixed. Okay, we can't change it. This is known as uh, 10, and this is known as head. Okay, head. I would say this is head, and this is known as head. This was about this symbol. I hope something you are understanding. Just have a look for a few seconds. Now I have one example. There is a box, this box, and force is being applied. Force was applied on this box with some Newton, I would say, with 10 Newton. One person is forcing. This person is pushing with this much Newton. Newton is 10 Newton on this box. Of course, this box will move. Now we know that force is nothing but this is a vector because it provides direction. I am saying 10 Newton force is being applied on this box. This is a example. 10 Newton force. This much force was applied on this box, and the direction you can see clearly. Direction is in this direction. Force is being applied this much on this box in this direction. So you would say force is nothing but 10 Newton in east direction. You would say in east direction. This is complete your vector. And this, when you say I purchased how much 5 kg rice, 5 kg rice. You tell me, are you providing any kind of a direction in this case? No. Do you need direction for this? No. That's why this quantity is known as scalar quantity. But in this, you need a direction. There is a requirement of a direction. You would say, I applied this much Newton, but in which direction? Question is in which direction? You would say, I applied this much 10 Newton on this box in west direction, in east west, in east north direction. You would say, I applied 15 Newton on this box with rotation of 60 degree. So this 60 degree with rotation in which quadrant? You would say east north direction with a 60 degree angle. This is a complete direction, and magnitude is a 50 Newton. That is how you explain any vector. If you are taking force, that is how you will explain. Okay. You can ask me that, okay, can we only apply this much Newton in this only in this direction? No, it's not limited. It depends on you. Do you want to apply like that? This much Newton? I would say you can apply this much Newton in this direction, as well as in this direction, downward, upward, whatever you like, wherever you want to apply, whatever would be number of Newton. But it doesn't matter. Matters that you should provide direction and magnitude. If you are saying that you have a physical quantity and you are saying physical quantity, I have this physical quantity is nothing but vector quantity. So explain, brother. Explain that you have a vector quantity. Clear? No, this is very simple. When you are applying this much Newton in this direction, it is a very simple to say that in this direction, in east direction, it can be in a north direction, it can be south direction, it can be west direction. But when it comes to like that, this is not a proper direction. I would say in this in west, in north, in south, in north, we are not observing all this. This is like that. Let's say this is south, this is north, and this is east, and this is west. This is west. Okay. Now try to observe over here. A person is applying this much Newton force on this box in this direction. Can you tell me what is the direction? This direction is coming between east and north. We don't have exact one direction. And Kishan can also say that this rotation from east to north is how much? 60, I would say 65 degree. Like that Kishan can say. And from this given you will have clarity. If a question is giving 65 degree, this much angle from this direction to till this direction, you have this much angle. So in other way, you are getting clarity, brother. Right? So what is the direction for this? You would say in east north. Okay, in east north. Between east north. Clear? I hope you are understanding. Let me move ahead. We have this. Okay, we have this Cartesian plan. Uh, x-axis, this x-axis, this y-axis, this y-axis. Uh, Question is giving this vector like that. Okay, this vector like that, and how much Newton? Let's say 25 Newton. In this direction, 25 Newton, this much force is being applied on something. This much Newton in this direction. You would say this direction is coming between x and y. Am I correct? Am I correct? And you can name it. You can name it. Force. Let's just say this is force. So we can say vector F. Name of this is vector is nothing but vector F. And how much? Mm, how much Newton? 25 Newton. And direction is in this direction. Now you can also say that this 25 Newton in 25 Newton uh, in east to west. I would say in east to west, or you would with the 60 degree. From this, what are you observing? 25 Newton, it is magnitude, and from here to here, this is complete direction. In east to west, I would say not east to west, but east to north. With how much magnitude? So of course we will move from like that. We will move like that. So this is nothing but anti-clockwise. This direction is anti-clockwise, and when we move in this direction, this is known as clockwise direction. Clockwise direction. So this vector is coming between. If you have simple this question, from this question you can understand that this vector will come between these two axes. Okay, between two axes, and we are considering this axis as a east and this axis as a north. Clear? And with how much rotation? Rotation amount of rotation should be 60 degree, and here of course we can say east to west, means from east and we will end till the north. So of course from east we are moving from east to north. This is another way to explain any vector with a direction. Now next thing, angle between vector. Angle between vector. How to find angle between vector? How to find angle between vector? ANG. When it comes to angle, of course we will have two rays or two line segment. I would say two rays. So this one vector you will, I'm saying that you should have two vectors, two or more vectors, then you can you can have a angle. Okay, so angle between, how to find angle between two vectors? So this is one vector, let's name it, this name of this vector is a vector. Okay, this is a vector. Okay, okay, this is a vector. Now next is this b vector, this v vector. I have already told you that this ending part is known as a tail and this ending part is known as a head. This is a head, this is a tail. It is done. Now question is saying this rotation, this much rotation of this part is 45. Let's just say this is 45. If this is a 45, can you say that this side it would be how much? 135. This side would be 135. Angle between tail. Look at it. After this, I will tell you how to shift any vector parallel without changing direction and magnitude. Look at over here. If question is asking what is a angle between any between given two factors, but condition is angle you should have angle between tail to tail. Means so connection of those two vectors should be how, tail to tail. This is condition. So we have this vector like that, this vector, okay, and another is like that, a vector. We connected over here. But according to condition, we connected these two vectors in this way. You can see this a tail and this a tail. Both are connected in this way. Both are connected. Rather than doing like that, we could have done what? We could have connected like that, head to head. But question was saying something else. That's why we connected this tail to tail. And you can see angle. We are getting angle between these two vectors, where tail of both vectors are connected. Question is asking what is the angle of this rotation. So this is nothing but 45. This is nothing but 45. What if question says that okay, you are right, but other next question is find angle again, but now condition is you will have to connect the head of both given vectors together, then find the angle between their head. Now question is the same like that. Is it difficult to calculate angle between their what, between their head? No, this is not difficult. This is not difficult. I hope about tail, angle between tail, you are crystal clear. You will write like that, angle between vector A and vector B is 45 degree. Now let's see angle between their head. Angle between their head. One is like that and another is like that. Okay, this is A vector and this is B vector. These are two vectors which are given by the question, and question is asking what will be angle between head of these two vectors. So find angle between their head. Okay, between their head. Okay, brother. Just shift all this. Try to connect this head to head like that. We are not changing direction of this vector. Just we are shifting parallelly this two vector. Where head to head it can connect to each other. Now we are getting this angle. Let's say this angle is nothing but 60 degree. This angle is 60 degree. And name of this vector is A vector. This is a B vector. That is how you will connect head to head in any given vectors. That is how you will connect any two vectors tail to tail. Did you understand how to connect any two vectors tail to tail and how to connect any two vectors head to head? All things are in front of you. Just have a look. Just have a look. Just have a look. Now we are going to see how to shift any vector parallelly. For example, we have this vector which is this vector. It is going in this in upward direction with this much Newton, with 20 Newton. It is going upward with 20 Newton. Now question is how to shift this vector parallelly. Before we shift any kind of vector, there are some important points that we will have to keep remember in our mind. Those are first, don't change direction of given vector. Don't change. You cannot change this like that. Like that. Here we have changed direction. This will not be correct. Clear? To shift this vector. Number one condition is don't change the direction during changing the vector, during shifting the vector. I hope you are understanding. Okay. Now another thing, next thing is don't increase magnitude of a given vector. This magnitude I am talking about. Don't try to increase like that. I know direction is the same, I know. But what about magnitude? Magnitude in this case is more, and magnitude in this is normal. That's why this is an incorrect way. So what would be right way? So just magnitude should be same, 20 Newton, 20 Newton, not 35. Okay, this was second. And angles should be same. Angle or direction should be same. These were two two simple important things. Now you can shift like that without changing direction and without increasing magnitude. So you can shift this over here like that, 20 meter. Parallelly, we are shifting parallelly this vector over here. We shifted. You can shift this parallel over here like that, 20 Newton. Okay, got it? Okay, same it can go over here with this much Newton and in same direction. Same it can go over here with this much Newton in same direction. This is the correct way to shift any kind of vector without changing direction as well as magnitude. Now let's take some questions based on this, based on our concept. This was concept, okay. Little bit, I would say little bit, but this was concept. Let me bring some question based on this. Yeah. Now look at over here. We have this type of question based on our previous concept. Look at over here. Look at this first question. Remember, when it comes to find the angle between any two vector, then here there are some important points I would say to keep remember in your mind. Are first just observe, are uh, are both vectors connected to each other tail to tail, tail to tail? If yes, then you can see this given theta is our angle. Okay. For example, this tail to tail, both vectors are connected tail to tail. with some angle, and angle is a 60 degree. That's why this is correct. This is correct. We are getting a angle which is a 60 degree. It is a correct angle because both are connected to each other tail to tail. That's why. Now in this case, always remember when you are in the discussion of a vector, always take a angle which is between 0 and 180 degree. I would say 0 and 180 degree. It can be 0, it can be 100 degree, but not above the 180 degree. Not yes, not above the 180 degree. Okay, between 0 and I would say like that. Uh, what vector vector. Okay, 100 degree. In short, I am saying you you can take any angle, but angle should be between 0 and 80. 180, you can also take 0, you can also take 180. That's it. Okay, so here 60 is coming between 180. That's why this is correct. Now in this case 120, it is between 180 to 0, 0 to 180. This is between 0 and 180. Now connection, both vectors are connected to each other tail to tail. That's why this is correct. So our angle would be 120. So here you would say angle between a vector and b vector is how much? 120 degree. Now in this case you can see both are not connected to each other tail to tail or head to head. Yeah, both are connected to each other head to tail. Yeah. So that's why here it will be important to shift any vector, any one of them vector. Either you can shift this vector or this vector, so that we can get a correct connection of these two vectors. It can be connection of these two vectors can be tail to tail, it can be head to head, but not head to tail, not tail to head. Okay? So I am going to shift this A vector like that. And here you will observe that here this will be as it B vector, and just I am shifting this A vector. Here I didn't change direction as well as magnitude. And here angle should not be 150 degree. This angle is 150 degrees. So of course this will we will have how much of 30 degree. 130 plus 30 will be 180 degree. So now this is a 30, not 150. So angle between A vector and B vector is 30 degree. I hope you are crystal clear about this. Okay. This cannot be ignored, not at all. Same next question we have like that. Fourth question, like that question. An angle is given. Angle is given, which is 60 degree. But both are forming a angle, but connection is not correct. Connection is what? Head to tail or tail to tail. This is not correct connection. That's why we will shift any. Either you can shift this vector over here like that. Either you can shift this vector like that. So let's say we shift this over here and this will go downward like that. Now this is a 60 degree, it is upward and this is a downward. So 60 and 120 will be 180. So of course we will get 120. A vector and B vector. Now our angle is 120. This is our answer. This is better. 120 is better. 0 and 180. That's why this is entirely correct. This is entirely correct. Okay, that is how you will tell angle between two vectors when connections of those given vectors are correct. Incorrect with them. Okay. Now this is a triangle like that. Like that. We have this is triangle. Triangle can be made by taking three vectors, and it is possible to create an angle when you have three vectors. Then it is possible. Let's say this is A vector, this is B vector, and this is a C vector. Angle between them is a 60 degree, 60 degree, and 60 degree. Now tell me, angle between vector A and vector B would be it would be something, but we will calculate. Angle between vector B and C. Angle between vector A, B, C. C to A. C and A. Can you tell me? Can you tell me? No. If you are thinking that this would be 60, this would be 60, this would be 60, you are wrong. You are wrong. Let's calculate first of all the angle between vector A and vector B. So where is our vector A? This vector A, and where is vector B? This vector B. So here connection of these two vectors, you can see this is a head and this is a tail. It is in correct way. This is in correct way. Okay. So that's why it will be important to shift any of them vectors parallel. So this can go in this direction, then tail to tail connection will be tail to tail. So this side is a 60, so this side would be 120. That's it. So angle between these two vectors is nothing but 120. This is done. Now next we have angle this vector B and vector C. So vector B, this is vector B and this is vector C. Head to head. Connection of these two vectors is nothing but head to head. That's why this is a correct way. So angle would be 60 degree. Angle would be 60 degree. Clear? 60 degree. Now next angle between vector C and vector A. So this is vector C, this is vector A. Angle between this is a 60 degree. But connection. So here this connection is tail to tail. Connection is a tail to tail, which is correct. So that's why this given will be correct. 60 degree. Okay, that is how you will find angle between any two vectors. Connection, connection will find. Okay, after this, we will jump on types of vectors. Types of vectors. Are you ready? Are you ready? If yes, then let me know. Let me know. First of all, let me write. Then I will tell you. Types of vectors. Types of vector. First is equal vector. Next is anticolor. Then we have negative vector. Then we have coplanar. Coplanar vector. Then coinitial. Coinitial vector. Then orthogonal. Orthogonal vector. Then we have collinear vector. I'm telling you, definition of all these types of vectors are not so much difficult. These are not too much difficult. Once you understand it, then let's start understanding all of these vectors one by one. We are starting from equal vector. From this equal vector. Remember, equal vector is a vector. This is a vector. To understand this equal vectors, you will have to take at least two vectors. It can be vector A, it can be vector B, it can be vector R, it can be vector S, it can be vector L, it can be vector N, any vector, but two, at least two vectors. So two vectors clear, two vectors. Now, from word, what is equal? From word, what is equal? Equal means equal. This side and this side, both sides are equal. If this side is 5, so this side is also 5. Then both sides will become equal. Same here, similar here, I would say. Vector A, let's just say this vector, okay, like that. And another vector we have this B vector. Two vectors. As I said, we should have at least two vectors, and we got these two vectors. Now, magnitude. I am telling you definition of a equal vector. Magnitude should be same. Magnitude of both given vector, brought vector should be same. Direction also should be same. Direction. So let's say magnitude of this is I would say 5 centimeter, and this is magnitude of this vector is also 5 centimeter. So magnitude is the same. Magnitude is the same. 5 centimeter, 5 centimeter. Now direction, you can observe. Direction of this vector is in this, and direction of this vector in this. Same. Both are in same direction. That's why we can say these two vectors are equal vectors. Okay, this is a definition of equal vector. We understood this equal vector with this example. So in simple sentence I can say about equal vector is that magnitude should be same, direction should be same, not east, not west, only east, only west, only north, only south, in same direction. Okay, this is enough about equal vector. Now next we have parallel vector. Parallel vector. In the case of a parallel vector, magnitude will not matter, but direction will matter. Direction will matter. Okay, direction will matter. Both should be in same direction. Okay, both should be in same direction, and here angle will be 0. Angle will be 0. Both should be in same direction, but magnitude can be anything. It can be 50, it can be 100. If a magnitude of this is 10, so it can be anything. It can be 10, it can also be 20. Magnitude will not matter for a parallel vector. Direction will matter, and angle and for this parallel vector will be always 0. You can see this. If when you will shift this over here, then you will get a 0 degree angle. Rotation will be nothing. That's why. So what did you understand about the parallel vector? You understood that angle would be 0 and magnitude can be anything, but direction should be same. Okay, I hope you understood. So this part is also done. Next we have anti-parallel, just opposite of a parallel vector. Whatever we understood about the parallel vector, same opposite, I'm saying opposite of a parallel vector is a definition of an anti-parallel vector. That's it. That's it. So anti-parallel vector. Anti means opposite. One vector is in this direction, so another is opposite of this. This is meaning of a anti, just opposite, opposition party. Like that when we say opposition party. Now again I am telling you, for anti-parallel vector, we will not care about the magnitude, no, but the direction. Anti means opposite, just opposite. So it should not be in same direction. It should be up in opposite direction. Direction should be in opposite. Okay. If this one vector is going in east direction, so another should go in west direction. This is a complete definition of an anti-parallel vector. And I am saying again, we are not caring about the magnitude of this two vectors. No. Okay, this part is also done. This part is also done. Next we have negative vector. This is also important. This is also important. Look, negative of a vector. This is a vector which name is vector A, and magnitude is let's say 6 centimeter. Question is saying negative vector. Tell me negative vector of this given a vector. So just you would say just you will draw opposite of this like that, and what magnitude should be, magnitude would be same. We will not change magnitude of this vector. Just we will change the direction, and direction would be in opposite direction. So this was initially this was in this direction, and after doing something it became in this direction, because negative of this would be like that. So this is like that, negative a vector. You can say negative of this vector would be negative a vector. Magnitude would be same. Okay. Coplanar. 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 Plane planar. Co means compound, two or more vectors, not only two, two or more vectors. Now, in a plane, if group of, I would say, collection of vectors are in a single plane, then we would say this is the definition of a coplanar vector. Because collection of vectors are on a single plane. Let's just say this is a single. Of course, this is a single plane, and we can draw all these vectors. Even we have this four vectors, and all these four vectors are on this plane surface. I would say plane. That's why we are saying that collection of collection of vectors are on a single plane surface. Planar, you would say planar is the definition of a coplanar vector. Okay, this part is also complete. Coinitial vector. It is it is very easy, I would say, but just you draw a point, this point. Okay, coinitial. This initial point will matter in this. You can draw any vector from this point. Condition is you will have to draw any vector from this, like that. Direction can go in any side, like. Condition is vector should start from this point. This was about coinitial vector. Orthogonal vector, according to me, there is a one vector and another vector is nothing but it is a parallel to another vector. This 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 a vector is a parallel. This a vector is a perpendicular to this b vector. So here angle will be 90 degree. Angle will matter. Orthogonal, which means angle between two vector is 90 degree. So one vector is a perpendicular to another vector. This is an orthogonal vector. Okay, orthogonal vector. Orthogonal 90 degree. Collinear vector. Collinear vector. Collinear vector. It is a different from coplanar vector. Linear means line. So in a single line, in a straight direction, this is a single line. We can have two or more vectors. This there are, even we can see 1, 2, 3, 4, 5. We have 5 vectors. And condition was all this direction of all this vectors should be in single direction. Of course, all this are in single direction, and all this are on single line. So in simple words, I would say direction of all those vectors, collection of vectors should be in single line. Okay, should be in single line. Okay, single line, and that's it. And along a line, in same direction, along a line. Okay, this is also done. That's it about the types of vectors. I hope you understood something.